Welcome to this video lesson that discusses the orientation to engineering education, which is content from chapter 8 of the textbook. So what I want to talk about here is essentially how engineering is organized in an educational institution across the US primarily. While I'll give you some idea of what it looks like across the globe, the focus is primarily on what it looks like in the US. So let's begin with looking at colleges in the US within the context of the engineering field. So let's begin with some numbers. You'll be surprised to know that there are close to 2,500 four-year colleges and universities in the US, and which means that when it comes time to choose, you have of course many choices, many universities that you can choose from, and each one of us figures out where we would like to go based on various factors, including proximity, the cost of the education, the quality of the education, maybe the brand, the name of the university, and so on and so forth, right? So to give you a sense of how many of these institutions have ABET accredited engineering programs, in terms of an institution, there are approximately 26% of these four-year colleges and universities are actually ABET accredited. So that means 637 of them as of now, 2019, are accredited by the ABET. And also, by the way, ABET is an international accreditation agency, so you can find ABET programs around the world, and there are approximately 4,000 engineering programs around the world that have ABET accreditation. So if you are thinking about whether the quality of the program is worth going for or not, one thing you can check to see is whether it has an ABET accreditation. At the same time, it's important to realize that even if a program does not have an ABET accreditation, it could still be a very good program. So you need to look at a variety of other factors as well. Right? Now, when you look at a typical US university and you find an engineering department there, there's a certain hierarchy in which things are laid out. Right? Typically, an engineering department is one that is headed by a department chair or department head, and several engineering departments come together to form a school or a college. So when you think about a university, and within this university you see something like the School of Engineering or the School of Sciences, what that means is that within that school there are multiple departments, and if it's a School of Engineering, you'll find multiple engineering departments there. So for example, you might have civil, you might have electrical, you might have mechanical, and all of these come under the school, and this school is headed by the dean. And if it's the School of Engineering, then this person is the Dean of Engineering. Now, in the scheme of hierarchy, above the dean is somebody who looks at and talks to each of the deans across the different schools, and this is the Vice President for Academic Affairs or the Provost of the university. And finally, you have the President, or sometimes this person might also be called the Chancellor, depending upon whether you have one or more universities under them. Okay. Another thing to note is that sometimes what you might think of as an engineering field, for example computer science and technology, might actually be in the College of Science rather than the College of Engineering. Okay. So keep a lookout for some of these fields that are sometimes in engineering department or engineering schools, and sometimes in the School of Science. Next, I wanted to briefly talk about the role of community colleges in engineering education. So let's begin with getting a sense of why students attend a community college before they go on to get a four-year degree. First, some numbers. You might know that there are over 1,000 community colleges in the US, and out of these, 942 are public community colleges. That means they are paid by the local taxpayers who live in the vicinity of that community college, and so these are the public community colleges, such as Kenyatta, for example. It turns out that 52% of all bachelor's degree recipients in science and engineering across the US have attended a community college. So you can dig into more data by clicking on this link here, which is data provided by the National Science Foundation, and they give you a lot of numbers here. But if I look at, for example, the year 2015, which is the latest data available, you'll find that, sorry, let me just go back there. You'll find that about 1.26 million students received science and engineering degrees across the bachelor's degrees and master's degrees, and out of them approximately 52% of the bachelor's degrees recipients, so that means the total bachelor's degree recipients are about 983, so 52% of that of those students actually went to a community college, and that's a staggering number, right? So the community college, you can see, is an extremely important step in the way to getting a 4-year bachelor's degree in engineering. And when you think about it, there are certain things that a community college affords or offers. One is you can of course take classes at a community college that actually count towards your college degree. And the reason you might take that is because, one, it's affordable. Two, it's typically close to home. Three, you'll find that the classrooms are typically smaller in size and you get much better interaction time with the actual instructor and the faculty, as opposed to what you would find in a 4-year college. And I would say another very big benefit is that typically it's flexible. So you can be working and attending and taking a class at a community college that counts towards your final 4-year degree. Right? And also community college is a good bridge between a high school and a 4-year. It prepares you prepares you for what you're going to be doing in a 4-year college without being a significant transition from school to college. Okay, so the next thing I would like to talk about is something called academic advising, and you may have encountered some of this in your high schools, but it is something that becomes more and more important as you get into college and go through your 4 years in college. Right? Academic advising is basically something that is driven by you, and there's nobody who's going to push you into doing it, and it's something that you need to look out for and reach out for. Right? And of course, the single most important source for advising could be a faculty member whom you meet and ask for help. Right? And what they're going to say is that either they say that they can help you, or they will say, okay, I'm going to send you to this person who's going to be best prepared to help you with the questions you have. And so the sources for academic advising include faculty, it can be highly trained staff, it could be other students who are maybe 2 or 3 years ahead of you in your engineering program, who've done the same things and know how to overcome some challenges. And then also there are catalogs and student handbooks that are going to help you. So getting help is something that you should not be shy of, and it is especially important in the college because there you will not have your mentors and your parents around to help you on an everyday basis, and so you must be seeking help from the various sources that are around there to help you. Okay. Now, one of the things you should do is that you should have a roadmap, which is basically laying out all the classes you plan to take in each term during your undergraduate studies, right? And what you should do is you should share this with people whom you look up to, who can give you good advice. It may be a student, maybe of course it will be an academic advisor, and periodically check how you're doing at the end of each semester in the context of your roadmap and the classes that are going to be coming up. Okay, and you should be ready to revise it as and when things change, based on your needs and based on what's going on in the engineering program that you are enrolled in. Okay, so item number 4 is how an engineering degree can prepare you for other careers. So one of the things that we read about way back in chapter 2 is the kind of jobs or the job functions that engineers might have, and within that, we found that engineers are often in positions where they need to lead projects and manage projects, right? And what do you think a Master of Business Administration degree is all about? Well, it's all about learning how to lead and manage. So an engineering degree is almost one of the best degrees you can get in order to become a leader and a manager of not only of small projects but also big corporations. In order to get an MBA degree, you typically have to take the GMAT, which is the Graduate Management Aptitude Test, and so this gives you all the skills you will need in addition to your engineering background to actually let you be, for example, a CEO or a leader of a big corporation. Okay. Now, engineers, one of the other roles that engineers are involved in is that of research and development. And of course, as an engineer, you can be involved in that, but there is another way you can be involved in R&D, and that is through getting a law degree. Think about the people who are looking at the inventions that are developed by scientists and engineers across the world every day, trying to determine whether these inventions are new inventions, whether they've been copied and done previously, and all those kind of things, right? So this in itself requires a lot of research into what has happened, what is happening, what is the current state of art, and so on and so forth. So it turns out that so this should really be the LSAT. So this is a typo here. So what you need to take in order to get a law degree is to get the LSAT, which is the law school admission test. So law school admission test, and this gets you in a position to be able to get a law degree so you can be a patent lawyer. So this is something else that you'll find lawyers who are involved in corporations that are heavily engineering corporations, for example Tesla or a Google or an Apple. You'll find that their patent lawyers are basically people who are most likely to have engineering degrees as a background. And then, engineers are constantly applying logical thinking and solving problems of all types, right? And it turns out that that's what you need in the career that involves medicine. If you want to be a doctor is somebody who's using logic and training and solving problems. And so engineers are very well suited to become lawyers. In order to become an engineer, in order for an engineer to become a lawyer, to become a doctor, you need to take the MCAT, which is the medical school or the medical college admission test, right? So MCAT is the medical college admission test. And you'll be surprised to learn, by the way, this is Dr. Crumpler. She was the first African American woman to be awarded a degree in a doctor's degree, and this is in the mid 1900s. By the way, you'll be surprised to learn that amongst the students who go to medical school to get a doctor's degree, engineers are one of the top three disciplines from which students come. Okay, so finally, let me end with another item here, and this is graduate study. So sometimes, you will wonder whether you want to end with an undergraduate degree or do you want to eventually go on to get a graduate degree in engineering. So a graduate degree in engineering is typically getting a master's or a PhD in an engineering field. And why would you want to do that? Well, there are many benefits of getting an advanced degree. Now, one, you are getting more and more specialized, which means you are becoming one of only a few people around the world who might actually have deep knowledge about a subject, right? So you can become an expert in a specific field, especially if you go on to get a PhD degree. You will see that over time, those who have master's and PhD degrees earn an overall higher salary, a cumulative higher salary over time. So that's of course a benefit. And then the third thing, and I think the most important thing, is that there are many jobs that require advanced degrees. For example, if you want to be a teacher, you are better off getting at least a master's degree in a field, because it gives you many more opportunities. You can teach not only at the high school level, but also at community college level, and maybe at a four-year institution as well, right? So some jobs are best sought after only after getting a master's or a PhD degree. So with that, please read chapter 8 of the textbook, right? And make sure to follow up with any assignment activities that are related to this chapter. The homework is going to contain problems that relate to content in this chapter, so please do read through the textbook for additional information. Thank you.